All right, this is your Stats Sensei, and we're going to be doing our second example of computer printouts for regression. Look forward to going through this with you. So a study was commissioned by the Department of Energy to determine the relationship between the average monthly temperature in degrees Fahrenheit and the number of kilowatt hours consumed in Fargo, North Carolina. How nice. Data on electrical usage for homes for each of the 12 months of a year was collected, and the average temperature for the month was shown below. So we have all this information, and it says, the first thing it says is use the computer printout above to determine the equation of the least squares regression line. I see variable, I see coefficient, I know that information is here. I see constant, that tells me this is my y-intercept. And average temperature happens to be my explanatory variable. So this right here is my slope, and this right here is my y-intercept. So y hat equals 3,898.2 plus a negative 50.9027. Another way of saying this is electrical usage equals 3,898 minus 50.9027 degrees of Fahrenheit. And the advantage of writing it like that is I don't have to define my variables if I write it like this. Make sure you have the hat. If you don't have the hat, you're going to at least lose half credit, and you may lose all. Response variable, the amount of energy consumed, the explanatory variable, the temperature in degrees Fahrenheit. Anytime they ask you to write the equation, you have to include this, unless you write it like this, where the variables are defined inside of the formula. Explain the meaning of the slope in the context. Well, our slope was negative 50.9027, and we'll always put it over 1. So it really helps to sit there and write it just like that, and then do your explanation. So on average, there is a 50.9027 decrease in the amount of energy consumed for every 1 degree increase in temperature. All right. And the reason this is a decrease is because this is a negative number. R squared. They'll always give you this. That's a distractor. This is R squared. We'll just say R squared. Do never use R squared adjusted. So our R squared is 91.3%, and 91.3% of the variation in the amount of energy consumed can be explained by changes in the temperature. All right. The next thing it asks for is the correlation coefficient. Interpret this value in the context of the problem. Well, the correlation coefficient, we can just take the square root of R squared. So in this case, we had 0.913. And we take the square root of it, and we get 0.9555. But one other thing we must do is we need to check the sign of our slope. And our sign of our slope is negative. So in this case, our core R value is negative 0.955. And we have to say, in this case, that is a strong relationship. And we have to have we have to have these 3 words: strong negative linear relationship. Strong negative linear correlation or relationship between what? Energy consumed and average temperature. What is the meaning of S? Well, S is 201.3, and that's the measure of the standard deviation of the residuals. So S is a standard deviation of the residuals and measures the amount of variation that we can expect in energy for a given temperature. So finally, what is the predicted value for temperature of 4 degrees and 43 degrees? Well, the predicted amount, we just plug in 4 into the equation, and we get this value. For 43, we plug in this amount, and we get this value. So those would be our answers. And we'd like to say, and I'd like you to say, on average, we would predict that we would consume 3,694.6 kilowatt hours if there was if the temperature was 4 degrees. And for the other one, on average, we do predict that we would consume 1,508.3 kilowatt hours if the temperature were 43 degrees. Okay. All right. This concludes the computer printouts. Real important, you know how to do everything. And you know what? I'm going to point one other thing out. Once again, I look at this and I go, you know what? Sample size. I can look here and go, it's 10, but degrees of freedom is n minus 2. So 10 equals n minus 2. So my sample size is 12. And sure enough, they told me it was 12 up there. But this is where the sample size comes from. I can take this value divided by 10, and I'll get that value. If I take the square root of this, I will get that value. Also remember, this divided by this will equal this. All right, and that is that's a big T statistic. That's a long way away, okay? All righty, appreciate you watching, and we'll see you on the next one.